it looks like we have a problem here about radioactive half-life or exponential decay. So let's see. Iodine 131 has a half-life of 8 days. In a particular sample, the amount of iodine 131 remaining after d days can be modeled by the function h, given by h of d equals a naught times 0.5 to the d over 8. So this is basically the half-life formula. A naught is the amount of iodine 131 in the sample at time d0, so the beginning of the first day. Which of the following functions k models the amount of iodine 131 remaining after t hours, where a naught is the amount of iodine at the time t equals 0. So in here, we know that there are 8 days. So we start off with h in terms of d equals a naught times 0.5 to the d over 8, because there are 8 days in the half-life. Half of the substance is gone after 8 days. But we can use this same idea to extend this. So in 8 days, so we have 8 days, but now I want to go into hours. We know that there are 24 hours per day, so the day units cancel out. And 8 times 24, let's see, that gives me 160 plus 32, 192. So that's going to be 192 hours. So that's the half-life in terms of hours, which means using this same formula, k of t should be a naught 0.5 to the t over 192. Now, if we go through here, we can say, okay, this one is not equivalent. This one, if I use power over power, 8t times 1 over 24 is actually 1 over 3t. So that doesn't help me. That's wrong. In here, flip-flop it. So 24 times t over 8 gives me 3t. Still not the right answer. But here, power over power, 0.5 to the 1 over 192 to the t power is 0.5 to the t over 192. That is what we need for our half-life in terms of hours, so our answer is D.